Hello everyone, it's Ali back here and welcome back to my stream. Um, we are currently at season 3, episode 3, and as you all know, and for those who don't, um, my name is Ali. I am a software engineer for many years. I've been working in many different fields lately, mostly in decentralized finance and blockchain, and especially derivatives and options. So currently we are at season 3, which is all about options trading, and we are currently trying to create an infrastructure for options trading and also um, implement it in general. So this is what our goal for this whole season. And we are working on a particular strategy called wheel. And first episode we spent um, the whole of it basically on theory about options and the different possible strategies that we could work on, and the particular strategy that's called wheel, which we started with. And also also the on the second episode last Friday, we actually implemented this UI, or I wouldn't say like UI. Basically, this is like a Jupyter book to calculate stuff. So we made this interactive tool that helps us to simulate our strategy before it goes live. And this is very useful already because we see some of the like how to say unexpectancies that we need to handle, of course, before it goes live and trading and so on. And yeah, I already explained it last time and before. We are not gonna be like directly jumping into the implementation and trading. We will do all the work around it, all the preparations, statistics, um, calculations, and so on, tests, back tests, and only then we will start trading. And still not sure where. So the options are centralized exchange, Deribit, or Binance. Could be as well, actually. I actually don't know if Binance allows you to trade a partial contract, so maybe this could be an option for us actually. But if not, then we might as well use the DeFi options for the settlement. We will explore those and see. Yeah, so basically that's it. Let's go back. So let's take a look at our to do, what we did last time. So I actually, after the stream, I separated them onto two different categories for the to do, so it's easier to track and focus on something. So like for simulation, we have the change strategy to not use multipliers for strikes and premiums, and backtest on real prices. This is what we're gonna be doing today. Maybe we're gonna even start with backtests. And so we can, I think, like here, change strategy to not we can like use different approaches there, so that's why I just postponed it. And also about the strategy itself, there are two things. They are actually related. I think it's one thing. So add waiting points to not always trade, but only when market position conditions are good. And the question mark here is like, what is good? So we need to define this first, and we're gonna use AI for that. And maybe related to previous, yeah, that's why I mentioned that. Simulate again to assign call at a lower price than assigned put, and fix. Question mark means like needs investigation, basically to not sell below purchasing price automatically. So this is what our rule should be. Like in market making, for example, we had a problem that we were not able to maintain our market neutrality, and we wanted to, And here we actually don't plan to be market neutral all the time. Like if we are gonna buy Ethereum, then we are gonna be just okay with it, holding it. Maybe we can like yeah, we can just stay in it. We don't have to actually sell it, you know. So that's the difference. So we need to basically tackle those and see like what's gonna go next. Of course, once we are like we are gonna do several simulations and we'll see if they we like the outcome, if like this is performing on most of the outcomes, then we could start working on our infrastructure for trading. But for now I think we can focus, and we should actually focus only on the simulations. Because this is the only thing that's different from the reality, and that's you're actually not losing money, and you can play around with different outcomes in here. So we have a project here, if you remember. We were using Claude somehow through VS Code, which still was spending my Copilot tokens. So yeah, by the way, give me 1 second, I forgot. Okay, all good now? Yes, all good. So um so I don't know like if I like this approach, because here we have like more poor UI. We can just directly use Claude, I think this time. We'll check it out. What we've got here. Okay. Here I have the project. So let's start the dev server, and at the same time, I think we can just start Claude here. I think I still have lots of it. Yeah. Okay. So where we were at, we were at that thing that we were buying at a lower price, right? It's like here, when, or selling at a lower price, basically. So here we purchased it, and then we sold it here. So as I told you before, we need to mitigate those, so we will not be selling. But like, of course, here when we sell options, we have like obligation to sell at some point if the price goes up. So this was actually the problem of just selling options too low, probably to the current price. That's why it's happening more often. So we need to, I think, try different approaches. One approach would be if we just sell options with strike prices much higher. Yeah, I think we probably it's better that we like change this first, actually. And yeah, this would be like less happening less often. Um, yeah, like yeah, let's restart. Okay, so I'm gonna need to load my context as well. So if I'm gonna be like, you know, thinking slowly, never mind. Just let me do this. Okay, so let's run the code and let it learn. In the strategy simulation, how does the logic work? Currently, we probably need to write documentation. How currently for picking the strike prices and guessing the premiums. Oh, hello. Have my junior developed arrived here? I guess we're just gonna see it like this for some, unless I need my second hand. Okay, so let's take a look. Here's how the simulation currently works. Strike price selection. The logic is purely percentage based from the current spot price at the cycle open. Short puts use the same, basically they same use the same offset, right? Strike offset. Yes. So they just use the same offset with the difference that for puts it goes down and for calls it goes up above the current price. The user can adjust the offset from 1 to 20% of the out of the money. Default 5%. It's recalculated fresh each cycle based on the spot price at the moment. Okay, makes sense. Premium estimation. I mean, not doesn't make sense, of course, but it still it fits with what I had in my head. And premium estimation. Premiums are flat percentage of the strike price. The formula for puts and calls. Yeah, so they have the same. Key simplification: no option pricing model, no Black-Scholes, no volatility surface, no time to expiry sensitivity. Same premium percentage for both puts and calls, regardless of moneyness or market conditions. No adjustment for volatility, even though prices are generated with the configurable annual volatility. That volatility doesn't feed into premium estimation. Yeah, okay. Probably we need to improve this somehow. And let's check if it's possible. Maybe make the premium estimation more realistic using Black-Scholes. Oh, it already offered one. How can we change it so it how can we change it so it is more realistic? The biggest unrealistic aspect is the premium estimation. The flat percentage of the strike ignores the key drivers of option prices. Here, the main improvements, roughly in order of impact. Black-Scholes pricing, biggest win. Delta base strike selection. Real traders don't think 55% of the money they sell 30 delta put using Black and Scholes delta to find a strike for a target. Okay. Implied volatility versus realized volatility spread. We could add AV premium parameter so the volatility used for pricing is higher than the volatility driver. Yeah, I like all those. Let's just do it. So it's planning now. So yeah, basically what let me just explain you what it offered. So I told you already before about the strike about the formula called Black and Scholes, which is used to calculate like statistically the best price or like the most fair price of the option on the market. Um, I think there are other methods, but this one is just I think most efficient. Okay, here is the plan. Let's take a look quickly and start. The wheel strategy simulator. Okay, new file Black and Scholes. Modify wheel with a different config. Um, okay, I think let's just let it go. Yeah. So basically, considering that here we are, oh my god, it's full of fur. Considering that we are simulating the market here, we can also calculate everything that's required for the Black and Scholes, and we can actually, instead of using this stupid formula of where is it, premium percentage of strike, this is like completely stupid. We will be using like calculating on the fly real premiums that how they could potentially cost it on the market at that point. And with the strike offset also what it offered, I don't know like what will happen now. We will read now through this again, but for the basically there will be target delta uh, instead of percentage from the strike price. And this is what I told you here. The delta is basically how option price is sensitive on the asset. Like the biggest delta, it more behaves like asset itself. Like for example, here you can see the call options for 1,700. It's like already behaving in price differently with the asset itself because like the rest is just paying payout of the in the money option. I hope you get it, like because for the calls it's already like payout above this one, right? So the price difference between the price of the option is always like the strike price minus the current price, or current price minus the strike price. That's why it's like always tracks 1 to 1. And yeah, so like if we choose 10 delta, like for example this one, it's gonna be taking like just this. If you will choose like 1% delta, then we will always get strike prices like this, which is like the least paying option on the market. Okay, so I guess it did something. Let's refresh. Maybe it's already available in there. Whoa, so many params. Okay, so build succeeds. File everything. Okay, okay, okay. And now let's take a look at the params. More params now. Target delta is 0.3, which is like very close, I think. Very close, very risky. Well, that's why like we still have here, you can see. What if we do like this? Then we are more profitable. And probably this is what we want to run. Um, okay, well, I just asked it to add a APR calculation. I don't know. Just wanted to do this. Not sure even if it's good or not. Um, okay, so that's the problem, but also the good part of it. Like as you can see now with the smaller delta, we are like unrealized. Like you can see, we only were assigned once, which is like, yeah, cool thing. You remember before we were assigned all the time, up and down, and that's the actually that's the that was the problem why we were losing money, because like we were buying Ethereum above the current price and then selling it below the current price and again. And now instead of doing that, we are selecting much higher prices for buying and selling. And because of this, we have smaller premiums, but yeah, you can see the APR here now. Maybe it's good, but can you make these cards smaller? They now take 100% of width, and they actually can be shown in one line. Yeah, so with selecting the higher strike price, or like the farthest strike price from the current price, we are actually like receiving less premium. As you can see here, like the premium goes down, but also we decrease the risk of assignment, which is which is which is for us basically leading to not assign again and again and again. And here you can see we earn a lot of money on premium, like not a lot, but steady income on the premiums, because we are never getting assigned, so we never have a realized loss or profit as well. But you can see here, 1 second. You can see here we purchased here Ethereum once and we were holding it even though it went down, but it's okay, like we wanted to hold it, right? So that's why we don't care about this unrealized, because we just hold until it goes up. We can simulate now more days. Okay, so it was a good APR. And PNL. before we got assigned again and our loss was actually realized. So here, what we can do is actually just have an idea. Let me just write it down because I'm not gonna be discussing. I'll explain you later. I'm just gonna make a note for myself. Different target deltas from different situations. For example, if current price more than purchase price, then calls target delta is very low to increase premium and sell at higher price than we purchased. Exit early. Don't wait. Yeah, since it's a new thing, we are gonna oh, come on. Okay. Yeah. So I have a couple of ideas here. Let me just quickly explain it to you so you don't like, so you're not kept waiting for it, but it's for later. So one of them is to have different target deltas on different situations. We are going to implement this later for sure. For example, like now we have delta of 0.1 everywhere. So we like decide the options, puts, and calls. They are basically, their strike prices are the same distance from the current price. But what we can do is actually like imagine we purchased if we purchased option here and price goes up now, or like for example we purchase here and price goes up, so here we already can sell it, so we already make money. Our unrealized PNL is positive and we already make money. So what we can do is actually we can choose a lower, much lower delta, so we have better premiums. And yes, we are risking to get assigned, but if the price is already above, if the next strike price is already above our purchase price, we don't care. We will just also earn money on top of that. And of course, it's a game like of optimization of when to do this more efficiently, but we will do this later. I mean, this is just an idea of how to keep it, like how to behave differently in different situations, basically. And the same with here. Like imagine if we are like this situation. We purchase here very at a higher price, and here we are always like selling. You can see higher. We still collect premiums, but at some point here the growth was so much, then we had to actually assign and sell here. But we didn't want to do. And if we could have sold it like at this point here, we know that the price is lower than the purchase price, and in this case we could have just used a higher strike price for the calls than this one. So basically, if you see this dotted blue line, when the let me tell you like this, like when the blue one is like higher than the red one, so like when the current price is above, or like when the current price is above our put assignment, then we can have smaller deltas, and then if it goes down, then we can have bigger deltas for the calls, like for example. And we can do the same idea for the puts, but with different outcomes, or like with different conditions and different outcomes, and so on. So yeah, so this is one of the ideas that I just got here during looking at this chart. And also the second one here is exit early, don't wait assignment. This is another idea, is like, for example, um, imagine we purchased here, like we can have two of those actually. Oh my god, I have it, since it's a fresh project, I have many ideas now coming up my hand, so that's my head, that's why I'm just writing down everything. But yeah, I like new projects all the time, especially because they just plenty of ideas before you actually like get stuck in the project too much, so your brain stop like stucks in the routine and stops uh, creating new ideas. So it's like, yeah, I need to find an approach for myself, and this is like why I'm doing this smaller projects, because like I can have my brain more efficiently working on the brainstorming basically on what's happening if it's fresh. So one of the option here is stop loss, so we can get rid of our option before we um, are actually losing money or assigning. And exit before assignment. And also what we can do is we can exit early if take profit. We can take profit basically, like imagine, let me take a look here where we can do that on our current chart. Imagine, for example, here we sold here we sold put option, or here we sold put option, and then the price goes up. So instead of like, holding it this whole time, what we can do is we can actually just define where we take profit, and we could have sold it just right here. And um instead of like keeping holding the same, we can just take profit here, and then earn another premium on another option, and like sell another option with put option with a higher strike price here, and just earn additional money. What we can do here, calculate like PNL in old position versus PNL in new position to consider that. So yeah, we can calculate like how much money are potentially we earning if we are re-entering the market on a different conditions. Um, yeah, so that's cool. I have an idea here for the cloud. Um, params are too much now. Can you at least group them and the spread wider instead of one vertical line? We can see like what these params are responsible for. Yeah, as you can see here, we were assigned, and our unrealized PNL just dropped our realized PNL. Oh my god. Yeah, now it's cool. Okay, much better. Okay, for now, our wheel.ts is basically our strategy. We are gonna have to refactor it later and cover it with tests. But for now, yes, it can be like this. Yeah, so here we have a new three inputs, risk-free rate. I think it's for Black and Scholes. Yes, bid-ask spread percentage. E per trade. Yeah, and this is IV premium over RV. So it's implied volatility over realized volatility. Okay. And we are already at 30% of usage. But I have additional free credits that were gifted to me, so we are gonna use those as well. Don't worry. Okay, cool. So we actually implemented this simulation in strategy to not use multipliers for striking premiums. Bam. Backtesting on real prices. This will be do later. Um, so let's refresh and see. Again. Yeah, I'm just gonna be, running it over and over again and see if there is any insights that I'm looking at. Like, as I told you before, I have no plan here at all. So I'm just observing, thinking here online out loud. And of course I'm gonna be Googling and chat GPTing or like asking AI stuff. So yeah. Just sharing here with you guys my approach to do stuff. So what we said here is that target delta is 0.1. That's best for us. And we want to simulate more dates. Let's take a look here. If we made up. Yeah, so here is the moment like when you can take profit actually. At this time instead of waiting and risking. Especially since unrealized PNL is already grown. Let's take a look what's happening. You continue. Yeah, then it gives us negative PNL and APR, so not that good strategy. Let's try different seeds. So let's start with 0, 1. So if we trade for 1 year, minus, 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 plus, 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 minus, minus, plus, plus, minus, minus. Interesting. If it's possible that we, I don't know. I was thinking like, to implement, to like see the statistics of when our strategy gives us like positive or negative results, positive, negative APRs. So we can just simulate all those at the same time, like, 1000, for example, different random markets, and see like what's our winning rate basically. Um, maybe a good idea actually. So we can like visually see at least like we are on a good path for our strategy or on bad path, like that statistically it will just, this action will lose money. So let's I don't know if we need to compact, but let's compact. Just okay. Let's implement the compaction. Okay. Um, let's. Okay, I want to have something like win rate param for the simulation. How I see it is here. You say your thoughts. Um, we have a seed for the random. What we can do is actually just run the strategy again and again with incrementing seed. For example, from 1 to 1000, and calculate what's win rate of the currently defined strategy and params. Optionally, we can also calculate distribution of the PNL and APR. So distribution just for the statistics. I don't know what's best way to implement that. If we will just recalculate all of it all the time, then okay, maybe it's worth restructuring a bit the UI and come from generating simulation for different seeds in a list, and we can just expand one and observe closely with a detailed view as we have right now. Okay, I think it might get my idea, so let's just take a look. Like what I see here is, for example, like now we have basically one run here. So what we can do is we run like 1,000 simulations, or like, I don't know, 10, then we can add, or we can decide just to run 1,000 simulations. Then it runs 1,000 simulations. It tells us like what's our win rate. So basically when we are just above zero, and what's the distribution of our payout P&L, like how much money and how often we earn with this strategy. Monte Carlo analysis. So basically I came up with something that's already there, I think. Let's take a look. What's the Monte Carlo analysis? Oh, exactly. My computerized, I like at least from the look of this chart, it's already clear that this is exactly what I'm doing. Monte Carlo analysis is a computerized mathematical technique that models uncertainty by running thousands of scenarios with random input values based on the probability distribution. It converts uncertain variable inputs into a range of possible outcomes and their probabilities, allowing for better risk assessment in projects, finance, and engineering. Yes, we are doing exactly Monte Carlo analysis. So yeah, and then we can like click on each particular simulation if we like. Like we can always work on with the first one, and then we can like see what like basically it will open a view like this, and we will just continue analyzing this particular trade, for example. Also, probably this is the moment when we actually can also test it on a real chart of real, like back tested basically on the real price of Ethereum. Or at least we can have an abstraction for the strategy simulation, so we can like enter different modes like random and backtesting, because backtesting could be done also on different charts, right? So we need some optionality here as well. Yeah, guys, it's crazy. Like doing these simulations now, like this, just vibe coding UIs. Like I have many ideas coming to my head now. That I'm looking at it. Like we will probably see some of those implemented in a while. But I'm just remembering the times like 5, 6, 7 years ago when we were simulating everything like in Excels and code base. We were writing a lot of code base. Of course, like it was the AI now. The approach is completely different. Like we're definitely it's something magical. Good morning. Do you recommend any trades today? Well, I do not recommend any trades ever. Let's start with this, Chris. But I'm recommending taking a look at different strategies. They work differently on different markets. I don't know, like recommendation based trading. I don't know if it works actually. Um, okay, let's take a look. Oh, the plan is not ready yet. Like, of course, we can take a look inside what's happening here and try to guess it, but okay, we have the plan. So it's huge actually. Wow, it even thought about the RAM. Okay, so simulator currently runs a single simulation with a fixed seat. The user wants to understand the win rate and outcome distribution of a given strategy configuration by running many simulations with different seats. Monte Carlo analysis. The UI should be restructured so Monte Carlo summary is the primary view with the ability to drill into any individual run for the existing detailed view. Yes. Architecture. Two-tier data strategy. So store only lightweight summaries for all n runs, which is like 96 kilobytes. Recompute the full simulation result on demand when a run is selected. Makes sense. This avoids holding 17 megabytes of daily state arrays in memory for 1000 runs. Yes, makes sense. Performance each simulation takes 3 milliseconds, 200 runs, 600 milliseconds, 1000 runs, 3 seconds. Synchronous execution is acceptable for the default 200 runs. Changes. Okay. Yeah, okay, let's just start like this. It was thinking for so long. Let's just let it dry, let it do its job and come up with something for us interesting. We can actually, I think, commit this for sure because it's a meaningful change that works by itself. Well, if your strategy sees anything, I'm willing to take that risk low by 0 day trading. Puts today is how I'm feeling. Okay, I get it. You know your drill. Um, yeah, well, like I can tell you my idea why I like wanted to make the strategy in the first place, and maybe this will give you an insight. Definitely not a financial advice, but some insights maybe. Like yeah, if you're willing to buy ETH, then you can just sell puts like as crazy, right? And at any price and earn premium. Or like if you have ETH that you're willing to sell, also you can just sell calls, which is what I described like last time, like smart buying, smart selling. You're basically just selling options unless you're assigned, and like you're not only selling or buying your asset as you wanted to, but also you get some premium on top of that. This could be a good deal. Also, if I normally just collect from premiums. Yeah, exactly. That's what I'm talking about. And also, yeah, if you see that the volatility, like you can trade strangles or something like this, like just sell or put, or sell or buy calls and puts. So just short or call or long volatility. I guess. I'm still learning here as well, Chris. So maybe I'm gonna learn something from you. Just let me know how it goes with you. Okay, so it wants to build now. Probably it was already finished. We can refresh and see. Wow. Win rate 43%. Wow, this is really cool. So it does 200 of them. Yes. Cool. Explain how to read this tool now. Let's just ask it. It will be easier. So you can see we have a win rate 43% here. So let's take a look. If we will just change delta to 0.1, then we have win rate like of 70%. This is like, yeah, if something wins you over 50%, this probably makes sense to run. I don't know. But yeah, this one probably came out. Days to simulate 355. Okay. So that's a different win rate we see here. Um, okay, so this is how to use it. Parameter stop. These cards control the simulation. Market sets the start price, number of days, volatility, drift, and number of simulations. How many random price paths to generate? Default 200. Every parameter change reruns. Every parameter change reruns all simulations. Strategy. Target delta, IV premium. Cycle length, contract size, and the costs are risk-free rate, bid-ask spread, and fee per trade. Monte Carlo summary. So this gives you big picture across all N simulations. Win rate, percentage of runs where total PNL was positive. Green if more than 50%. Red otherwise. This is the core question. How often does this strategy make money? Average annualized return across all runs tells you the expected return. Median APR is the 50th percentile return, less skewed by outliers than the mean. If median is much lower than mean, a few big wins are pulling the average up. Yes, like, yeah. Outcome distribution to histograms, APR distribution, how reruns are spread, green bars winning runs, red bars losing runs. We have some intersections here. Average worst peak to through drop in a total PNL tells you how much pain to expect mid strategy. Yeah, this one was like almost the whole Ethereum, like Ethereum went down. So you see it makes the win rate just a little bit more accurate. Yeah, so now it makes more sense. As you can see, like if what's the problem here? Like I just dropped the target delta to the low value, quite low, and it's still like win rate is 40%, is less than 50%. So on the long run, this strategy is bad. Like we did not improve it anyhow, to be honest, yet. Like we just changed how we calculate the premiums and so on. So we just changed the environment it's running in, but still, we have much better instrument now to simulate and analyze. Um, what if we run it like on 1 month? On 1 month, the win rate is better. So this probably means that we shouldn't just constantly trade. We should take a look at the market conditions and see what's the best market conditions when we need to trade this. I think we can analyze all that based on what we are building right now. Actually, we'll be curious to actually run it, then backtest it on real data. Maybe it's actually a good thing to wait for that moment for a little bit, because we can like test our strategy now on randomness, find all these good bad approaches, tune the strategy completely and so on, make sure it has a good win rate on our simulations, and then we turn on the real data and see, like, because if we will turn it now, we will just get the same results. Doesn't make any sense. But then it will be just interesting, to see like when you apply already directly to the real market, even without knowing it before, without checking it or like tuning it according to it. I wonder like what's gonna be the win rate there. So you can see mean and the median. So if we run it 2 times more longer, like for 2 months instead of one, then the win rate drops significantly from 72% to 60%. So let's here see. So what if we run it for 3 months? It drops again. It drops like almost to 50. Okay, so this strategy, what we have so far, is already good. Like let's go back to 30. It's already good for a 1 month runs. Most of the time you will win. Yeah, but if we return delta back to this number, this is already not that good. What we can also do is check if we do daily options instead. Daily options. Yeah, so the longer options we take, it actually, like, take a look here at the weekly options. We have the win rate 72%, and at the daily options, it's already 51. And if we increase it to 30%, then it's already worse. But actually, the sensitivity here is not that big. Like, take a look. 51, 40, just 10% difference. But with the weekly options, it's like almost 50% difference. That's also interesting. What if we take like 2 weeks options, for example, instead? So we actually have a better rate here with 2 week options. What if we take monthly options? We are, what the fuck is this? Okay, we cannot, okay, sorry. Let's go back here to 1 year. I think it's more interesting. So here, if we do weekly, you remember, it's 40%. If we do daily, it's 33%, so it's less. And if we do monthly options, then it's actually increased. Interesting. Would be interesting to somehow, compare different strategies. I don't know, like maybe we can save here. I don't know yet. I'll keep it in mind for now. Like I was thinking, like now, okay, we have all the simulation makes sense. Now I wanted to try like what this idea that we talked about to have a different deltas. Okay, let's try doing this. Let me first commit what we've done here. I think it's very cool. Um, I don't know like how to check your current like context window. Okay. Anyway, so maybe let's take a look. Yeah, let's do this idea that I had. I think we can try different target deltas for different situations. Yes. So let's improve, or maybe we can just compact it for once again. Let's think together first. So let's take a look here. Here we were assigned, and then we started to selling calls, and here we were assigned again. So we were assigned again. So I wanted to use different. Like I wanted to use different deltas, yes, for the strike prices if we really don't want to sell, right? So like one of the options, of course, is to basically just pick a strike price that's above your purchase price. Maybe it can offer us something. So I have the idea to improve the strategy instead of always enter positions with a fixed delta, change it based on the current situation. For example, we were assigned on put, so purchased ETH, and the price goes up. So if so we are already in profit holding ETH, and we can sell all options more aggressively with basically higher delta, right? Yes, with higher delta. And if it's below purchase price, we can sell them less aggressively with a higher delta or with a smaller. Same for puts. What do you think? Any improvements potential? Anything to consider too? Let's see what it thinks, but I think it makes sense. And for the puts, it's gonna be probably the same. I don't know. Like, let's see. This is a cash basis strategy, right? So we want to earn more cash, and we want to exit in cash. So basically, we are willing to. I don't know. Like, what's the situation if we sell puts more or less aggressively? Like, I don't understand the idea here. Why it makes sense? This is a solid idea. It's essentially adaptive delta targeting based on position. Here's my take. Why it makes sense for covered calls: if in profit, price more than entry. Higher delta means more premium collected per cycle, higher chance of assignment, but that's fine because you're selling ETH above the cost basis, locking in profit. Alterate cycle completion, capital freed up to start fresh. Yes, exactly. Underwater. So if the price is less, then you avoid getting called away at a loss. Still collecting some premium to gradually reduce cost basis gives price time to recover. This is a rational risk management. The asymmetry is in your favor. For puts, less obvious but still useful. You don't have an existing position, but you could scale delta based on how far price has moved from a reference, starting price or a moving average. Price elevated, lower put delta, less aggressive entry, future out of the money strikes, further out of the money strikes. Price pulled back, cheap, higher put delta, willing to buy at a strike closer to spot. So the logic here is you'd rather get assigned on ETH when it's cheap rather than when it's at a local top. Okay. Things to consider, more parameters to tune. You'd need the main delta, max delta, and the scaling function. More knobs, more overfitting risk in backtesting. What the fuck is this? Sustained downtrends. Low delta calls on underwater position collect almost nothing. Yeah. As you're just sitting and waiting with no income. Yeah, basically that's what I thought. Maybe we shouldn't even do this, especially if we're okay with holding Ethereum. Scaling function, linear interpolation between bounds is simplest. Okay. The Monte Carlo framework is perfect for testing this. You can compare fixed delta with adaptive delta across hundreds of runs and see if win rate, mean APR actually improves. Want me to implement it? Apply to puts too. Yes, good idea, but let's discuss more. First, so you are saying that maybe underwater it's better to just wait instead of sell cheap options. Um, if so, is there a way to like somehow calculate this? Also, a second one was about puts. About puts, I still don't understand it well. So basically, your idea is to just buy cheaper. Any other reason to use this on puts? Hello. She comes a lot today. So I hope you like her. It was very noisy, so maybe that's why she wanted to go come to and cuddle, you know. So cheap calls versus weight. The problem with out of the money calls when underwater isn't just that the premium is small, it's just you're capping your recovery for almost nothing. Say you bought Ethereum at 2050, price is now 2000, you sell a 10 delta call, which is 20% of the time, you pocket $20, nice but trivial. 10% of the time, price rips to 4,200, but you sell at, you give up 200 of recovery for $20. The premium is theoretical, fair price for that upside you're selling, but after bid ask spread, you're selling it at a discount, so the math can go negative. You can calculate a skip threshold. Don't sell when expected premium after fee spread is too low relative to the position size. A reasonable minimum premium threshold could be percentage of the capital at risk. Below that, the premium isn't worth capping your upside. You could also factor in how deep underwater you are. The deeper you are, the more upside you need to recover. So the higher the bar should be selling calls. Okay, makes sense maybe. And puts, honestly, it's weaker. You are right to push back. For puts, there is no cost basis to protect. So adaptive delta is really just market timing, betting that price is cheap or expensive relative to some as a reference, not directional view, not risk management. And the Monte Carlo simulation uses random walks, so any mean reversion logic won't show consistent benefit against GBM pass. I don't know what's GBM. I'd say skip adaptive delta for puts. Keep puts at a fixed delta. The real edge is on the call side, where you have a concrete cost basis driving the decision. Yeah, I agree. So instead of generic adaptive delta, the call side logic should be scale call delta based on PNL relative to entry, more aggressive when profitable, less when underwater. Keep selling calls entirely when the net premium falls below a threshold. Just hold and wait for recovery. Yeah, okay, so let's keep that on 1 second. Okay, let's do it. Also now we grow the we are growing the strategy, making it more complex. Let's write down and keep doing it in the UI, all the strategy rules as a list, so we can simply like an algorithm for manual trading, for example. Okay, so basically we will now implement this strategy, and this may actually drastically improve our win rate for this strategy. Let's also take a look on what I had here. To add waiting points, do not always trade, but only when market conditions are good. I think this is what we are basically doing right now, right? So okay, while it's cooking, let me just play around with it a little bit more. Maybe I'll have some more insights. Yeah, looks like it's done. Okay, so you can see now already that win rate is definitely increasing. Now I'm just clicking it on and off. Okay, so skip threshold is 0.1%. I don't see that is okay. I don't have it adjusted like this. Doesn't affect the win rate actually. What affects win rate is probably this. Um, okay, target delta only for puts now. And if we keep it hmm, can you combine? You know what? I just want to move this cost config here to the market and this strategy rule to the right. I think it will be better visually. Um, small UI fixes. Combine config for market and posts. Separate with horizontal separator on the place of costs. Put strategy info rules. Also fix their height. So the adaptive delta threshold doesn't move the whole page up and down. I doubt. Yeah. Okay, I will just do the small fixes. Okay, I have a question here on YouTube. Let me read it. It's in Russian, so I'm gonna answer in English. Вдали проводится разработки ботов для маркетинга. Подписан на ChatGPT, используя код. Эти коды для генерации кода. Как тебе Cloud Code, стоит переходить на Cloud Plus про подписку. I think it really depends on your usage and what exactly you need. Like yesterday, I discussed with one of my yeah. Let me like just repeat the question. So the question is, the Rostrom is asking if he's trying to do some polymarket bots, and he has business and subscription to ChatGPT and uses OpenCode plus Codex 5.3, which is what I actually usually do as well. And he asks, how do I like Cloud Code, and should he go to Cloud Plus Pro? Yeah. So I think it's drastically like a lot depends on your use cases. Yesterday, like for me, of course, it's obvious, like the best model, always best model, because like like I do complex stuff, very complex architectural stuff and so on. Like I can do this myself most of the time, but it will take just much more time. So that's why I need smart model. Then I just review, and most of the time it gives me the best option. And like, of course, Opus 4.6 here like gives me best options ever. So that's why I like using it. And so it depends on your needs, and it was obvious for me, and I actually even didn't think about it before. And yesterday we discussed with one junior developer. He just started, and I asked what setup does he use. He said he uses Gemini CLI, and he actually uses Gemini 2.5. And I was like, how can you use Gemini 2.5? And he said, like, I don't need anything. Like, I'm like, he's a junior developer. He's only doing like he just started with the small easy stuff, like what was it? It was course on course headers, basically, on the HTTP. And then I thought, yeah, that totally makes sense. Like any old or any, like, not expensive and not super smart model can actually fix this kind of things. So that's the point. Like it depends on how much you want out of your model. And like this is what I just realized yesterday. So yeah, of course, was not even obvious for me. 1 second. But for example, yeah, so you understand like the difference, right? And yes, Gemini 5.3 codex is very good, but Opus 4.6, I think it's better. I don't know, like many people actually tell me that 5.3, if you make if you like, or actually even a lot of people talk about it on Twitter as well, if you will keep running it longer, so it just takes longer time, but it gives you the good output. So it also makes sense. So it's all about model, how you use them, and so on. This is the first thing you need to think of. And then the rest is like which provider gives you best options. As I was telling before, like I used Copilot mainly before. And you can see here, let me show you. You can see here there are many models in Copilot. So like you can use like this one, you can use Opus, you can use Codex 5.2. It did not release 5.3 yet. There is like Opus 4.6 9x usage. Like this one is super fast. I haven't even tried it, and people say it's super expensive, so I don't need it actually. Like I don't need it faster. I just need this one in just this. It's brain, not its speed, But for speed intensive tasks, you can do that as well. And this one actually, like the Copilot, for $10 only gives you a lot of requests, and for $40 it gives you much more requests. And Yeah, but like I was, for example, sitting on my also ChatGPT subscription, which I did not use actually, and I only started using it 2 months ago. I realized a lot of credits for me in there. So if you already have 5.3 codex, probably is not worth it for you to get any new subscription yet. Like you can just get used to this one. If you want to try out Opus, for example, how you like it, you can just get something cheaper for $10. You can get Copilot and use it, or you can get like spend it 1 month, just spend $20 for a minimum per subscription. I use minimum subscription here in Claude and see if it works for you or not. It's really, really personal. I think depends on how you use, and yeah. So I hope I answered your question. Like, of course, I don't know like what's the best solution. I don't even know like what's the best for me now. I'm still confused, but I see now I'm getting to see like, for example, for me it's very important to have this 4.6 opus. This is very important for me because this saves me a lot of time. Like I'm not doing basic coding stuff. I do complex architectural changes. As you can see, like we do a lot of complex patches immediately. They require a lot of thinking, especially now we are doing very complex derivative trading. So this model is not only coding for me, it's also thinking as a financial analyst or like a quant for me, and so on. So this really depends. If you know what you do and you just need, like, you don't have complex stuff, you want to think about architecture yourself, and you give precise instructions, you actually can use free models as well. Like this one, Grok Code Fast 1, is actually pretty smart. It's just, it doesn't have big context, but if you tell it what to do, it does it, and it's for free. So it's also a thing to consider actually. Okay, let's go back. Let's take a look what's happening here, because the options trading is so interesting. I don't even like follow the time, and it's already 2 hours almost for the stream. So let's take a look what we've got here. Okay, so now it's just, more beautiful here. Okay, so let's since it's like we already closing to the end of the episode. I don't really want to end, to be honest. It's really so fun here, and yeah, but I will, of course. I have to. Let's just quickly do some, I don't know, discussion on what we've done. See if we have any insight while the context in the head is fresh, and maybe even come up with some to-do list for the next stream for the Wednesday. So the idea was to adapt the delta on selling calls, and have more aggressive, higher delta on when we are profitable. As you can see here, now it moves from 0.1 to 0.5, and it's trading at 0.3 when it's break even, and when the premium is below 0.1% of the position, we just skip trades. I think here probably the values are too big. Let's make it like this. Wow, interesting. Okay, I think maybe it's like now, I don't know, like here with win rate, playing with around with win rate, I think makes sense when we do drastical changes like we just did. So I don't know. Look, we just improved it. Like if we if we trade on a monthly basis, weekly options here, right? So so the difference is if we just constantly use. Okay, you can see here, like if we constantly use 0.1, the win rate increases. But what if we use, I don't know why it's happening like this. Like it should be, this is strange. Because we sell puts on a lower delta. Is it the reason? So we buy less Ethereum. Hmm. Interesting to analyze. Okay, so we already implemented this idea. Um, we will keep those about taking profit and stop losses. Add waiting points not to place trade. So let's write down problems instead of. We are gonna be writing down problems here. Okay, the done part is gonna be here. Backtesting we will do at the end. At the when never strategy is perfect for wow effect, just to impress ourselves, you know. At waiting points, not always trade, only market briefing. Good. Maybe again. I'm not sure. Like we need to check if the assignment prices are actually correct. You know, that's probably the point. Okay, so this one calculates realized PNL always with the okay, so that's the problem. So we couldn't make it up. But this doesn't mean anything actually. Like, the question is here, should we call this event actually the loss? That's the point. Like, yes, current price is 1,900, and yes, we purchased it at this price. So we are kind of minus. Hope you get it. So we are kind of like minus here, but it's actually not realized P&L, right? So let's save. Wait. Let's save our changes here so we won't lose it. But the question is if we calculate it correctly. That's the point. Like, imagine here, okay, we sold one. We were not assigned. Okay, we got $18. That's cool. Then we sold another, and we got 19 more here. Then it dropped down, and we had to execute. But theoretically, yes, we purchased it below the market price or above the market price, and we are kind of in a loss. But if we haven't sold it, then it does not seem to me that that we are actually in loss. Like, here we still hold it. Why are we calculating it as a loss? Let's optionally disable that and see what's gonna be the difference in the math. Let's add. I see some problem. Let's experiment. I see that on during the trade, if we are assigned to put, you immediately calculate the price difference, strike market price minus strike price, and it drops the P&L, but it's unrealized P&L, right? Or no? Because if it is, then we incorrectly subtracted from the P&L. Regardless, make me box to calculate, because we did not sell it yet, so it doesn't matter how much it costs. It only matters if we sell it. Make a checkbox to calculate to disable this subtraction to check the difference in performance stats. Let's just take a look quickly at this thing, and I think we can just finish. Well, a lot of thoughts. Let's see what it will output. You are right to question this. Let me trace through the code to confirm. When a put is assigned, the current goes does. This subtracts strike minus price, mark to market loss, buying. So the same loss is counted twice. Yes, you see, that's the problem. So actually the strategy is performing well. I found it. So the same loss is counted twice. The put realizes a loss that hasn't actually been realized. You just bought an asset real. So when it's off, okay, let's take a look now. Let's refresh. Where is this button? You see? So this one should be good actually. And you can see here, we got assigned. Okay, we purchased Ethereum, but we did not sell it, right? So we were not losing anything. We sold a call above price. Then we waited and we sold the Ethereum somewhere here. And we earned money. Um, so it was a mistake, and we just need to never count it. So let's just ask it there and let's calculate again. So what happened here? We sold first option, right? We got $86 for it. Then the price went down and up, and we sold another one slightly lower price here. So we got like we were plus 172 at this point. Then the price went drastically down, but it was not realized, right? Because we did not sell anything. So it only realized here when it was actually at why the drop here? That's I don't understand. So we sold, we earned, we sold, we earned. Here we go down, we sold again, we earned, and then it was executed. How was it executed? So the strike price here when we sold again was 2,700, 2,070, and what was above? Probably the same error here actually. I don't see here any losses. Yes, it's a bug. The logic is straightforward. When a put is assigned, you buy it each, no losses realized, just an exchange of cash for asset. Current PNL always just let me remove the toggle and fix it permanently. Okay. But I think it's the same issue with isn't it The same for calls. Looks like an error too here. Good question, but actually the call side is correct. Here is the difference. Put assignment. Okay, can you change trade log? Now it has complex merged trade info. Can we have separate like sell option and buy sell asset? Let's just change it. Maybe I see something wrong. Okay, so now it's clearer here. You can see like first we sell put with this params, but this premium, so we have PNL like this. Then the put expires and we sell another put. Expires, nothing happens here. Then we sell another put. So you now have column for delta PNL. Say that explicitly. Also add column for total PNL. Also purchase price is missing. I don't like the table a little bit. We're gonna change it. I mean asset chase price from put assignment. Ah, okay. So that's the problem. I see now. I see now. Probably in this case, if we could have this threshold like 10%, oh, not even 10, 100%. Does it work? We have skipped selling calls here at this price. Okay. Entry. Why? Yeah, like entry more. Let's keep it entry. This. Already. Okay. And okay, now it's clear that we purchased this at a higher price. So we still haven't solved this problem. Okay, you know what? Let's finish for today. I think I'm gonna keep the to-do list like this as is right now. And I like this, so I'm gonna push the new table as well. What I think we can do is actually entry price. Visualization. Show entry price and the difference with purchase. Yeah, let's just show entry price on chart. Okay. So yeah, what was confusing here? Let me just tell you because it was just my insight, and I'll start finishing. What happened here is that this is our strike price, and this is our the current price when we were assigned, but this is not assignment price. That's why I got confused here. So we need to also place here assignment prices. Not only entry, also exit on the chart. Yeah, so basically the assignment price actually for how much we purchased it, it was here. So like, this is how much we purchased it. So we cannot like sell it below. Probably this threshold is not correctly working. So maybe we need to fix that. Bugs. Check if threshold is actually working. Yeah, so this is it. We are gonna finish for today. I think we did a great job. We improved the strategy drastically, and it's it's more often winning now. It works on many different markets. Like we just simulated on random market now, and I think it will work on any other market too. You just need to make sure that your strategy has appropriate behavior in appropriate places, and that's it. I really like doing this. I'm really looking forward for the next session for the Wednesday. Thanks everyone for joining for questions today. It was quite active. Um, Comparing to usual activity. Thanks for that as well. Thanks everyone for coming, for commenting, for giving ideas and asking questions and giving insights. Let's meet in 2 days on Wednesdays 3 p.m. as usual, Central European time. Oh, let's see. I'm getting tired already. So thanks again. It was awesome. See you next Wednesday. Thank you. Thank you.